So to understand the rest of the code that our AI is suggesting, we need to understand what are called conditional statements. Conditional statements in their simplest form look like this. We begin with the keyword if. Once again, a keyword is something that you cannot use as the name of your variables or indeed your functions. These are special words in Python. So we write the special word if followed by some condition, and then we write colon. And just like before, whenever we have a colon, on the next line we must put an indentation. So this series of statements, it could be one or it could be many, all these are part of the body of this if condition. When this condition is true, we will go ahead and do these series of steps. This condition that we write is usually what we call a Boolean expression. Boolean is named after a British mathematician, George Boole. Go read up George Boole's Wikipedia article to find out two interesting ways in which he was connected with India. Now, these Boolean expressions can be made up of various kinds of relational operators. You saw our AI suggesting the strictly less than operator. When we compare two numbers, if one is strictly less than the other, we will get the Boolean value true. And if it is not strictly less, we'll get the Boolean value false. Similarly, we have the greater than, the less than or equal to, which we just write with the less than immediately followed by the equal to symbol. So that is the less than or equal to operator. This is often also read as at most when we write natural language. Similarly, at least or greater than or equal to. And then equal to, this is comparison, not assignment, so we use double equal to. And this exclamation mark equal to is not equal to. This borrows from earlier programming languages like C, where the exclamation mark is often read as not. In Python, when we want to say not, we will just say the word not. But exclamation mark equal to is not equal to. By the way, these relational operators can be used not just with numbers like ints and floats, but they can also be used with strings. We can talk about one string being less than another if we are comparing strings in what we call lexicographic order. That's a very scary sounding word, but it just means dictionary order. So, for example, the word cat is earlier in the dictionary than dog. So the string cat is less than the string dog. Similarly, the string cat, C-A-T, is less than the string catch, C-A-T-C-H, because in a dictionary you would find the word cat earlier than the word catch. In addition to relational operators, there are other operators to check, for example, if two variables refer to the same object. And you can check, for example, if x is y, or if x is, in general, some other expression. And similarly, you can check if the variable is not some other object. Further, we have membership operations, in and not in. We will see examples of this in a later lecture. And then if we want to build complex Boolean expressions, we can use and, or, and not. We will again come back to these in a later lecture. Also, you will sometimes see expressions that are actually not Boolean. It turns out that any object can serve as a condition. This is an advanced concept, but since you will see code written like this, we will see this idea in a future lecture. For now, let us critique this AI-generated suggestion. I want you to pause, read the signature, read the docstring, and read the two doc tests to understand what the intention of this function was. And then with that understanding, go ahead and critique line 9, which is suggested by my generative AI.